Find the area of the triangle ABC. Label points G, K, and L. Join line BG, line KB, and line CL. Since AGECB is a semicircle, KBGCL is half of a square. It implies that line B equals line AK, line BL which equals 6. Also, line KL equals 2 times R minus 12 equals to 2 times R minus 6. Hence, line OL equals half of line KL which equals R minus 6. As shown on the screen, it signifies that line B equals line AK which is equals to line DL. The result is equals to 6. Also, line CL equals to R minus 6. Join line OC equals R. By Pythagoras' theorem, we obtained an equation for the square of line OC. Substitute values. We have that the square of R equals the product of 2 and the square of R minus 6, as shown on the screen. Expand bracket. The square of R equals 2 times the square of R minus 24 times R plus 72. Simplify and we have that the square of R minus 24 times R plus 72 equals 0. Use general quadratic equation formula. R equals negative B plus or minus the square root of the square of B minus 4 times the product of A and C, all divided by 2 times A, where A equals 1, B equals negative 24 and C equals 72. Substitute values. We have that R equals 12 plus or minus 6 times the square root of 2. After simplification of substituted values, it follows that R equals the product of 6 and the sum of 2 and the square root of 2 in units. Hence, the diameter of the semicircle equals 2 times R which equals the product of 12 and the sum of 2 and the square root of 2 in units, as shown on the screen. Solution to question 2. Required to find the area of triangle ABC. Consider triangle ALC. Line OL equals R minus 6 which equals the sum of 6 and 6 times the square root of 2, as shown on the screen. It implies that line OL equals the product of 6 and the sum of 1 and the square root of 2 which equals line BC. We call it equation 1. Again, line AL equals 2 times R minus 6 which equals the product of 6 and the sum of 3 and 2 times the square root of 2. This implies that line AL equals the product of 6 and the sum of 3 and 2 times the square root of 2 in units. And line CL equals r minus 6, which equals the sum of 12 and 6 times the square root of 2 minus 6. The result is equals to the product of 6 and the sum of 1 and the square root of 2. In units. Using Pythagoras' theorem, we obtained equation for the square of line AOC. Substitute values. It implies that square of line AC equals the sum of 720 and 504 times the square root of 2. Take the square root of the equation. Line AC equals the square root of the sum of 720 and 504 times the square root of 2. Consider triangle ACL. Let angle ACL equals theta. This implies that cosine theta equals line CL divided by line AC, which equals the sum of 6 and 6 times the square root of 2, all divided by the square root of the sum of 720 and 504 times the square root of 2. We call it equation Y. From triangle ACL, angle ACB equals to 90 degrees minus theta. But sine 90 degrees minus theta is equals to cosine theta. Hence, area of triangle ABC equals half the product of line BC and line AC times sine 90 degrees minus theta, which equals half the product of line BC and line AC times cosine theta. Substitute values including from equation Y. Area of triangle ABC equals the sum of 54 and the product of 36 and the square of 2. In units. After simplification of substituted values. Simplify further and we have that the area of triangle ABC equals the product of 18 and the sum of 3 and 2 times the square root of 2. In units.